Now, follicle stimulating hormone is doing something to a follicle. So let's just do a really quick and brief description of what is this follicle you speak of. Well, first of all, a follicle is a structure in the ovary that surrounds some flavor of oocyte. Think back on the process of meiosis and remind yourself that within one of the stages of oogenesis, the process of producing a fertile egg, one of the stages is to go through and create a primary oocyte. It's pretty fascinating how the ladies actually freeze their meiotic cells, like the cells that are going to go through the process of meiosis. There are only 500,000 of them in each ovary, and that's not very many. And they get frozen in meiosis. They get stuck in this primary oocyte stage. And they're stuck inside something called a primordial follicle. And I'm drawing little flat cells around this oocyte to show you that this is a primordial follicle. That's an R, primordial follicle. Now, follicle stimulating hormone. Who do you think the follicle stimulating hormone is stimulating? Follicle. And I'm not going to go into all the crazy details. We'll avoid those crazy details. You can go to anatomy to look for those. But I'm just going to do like a really quick, like from here, over the course of 14 days, and under the influence of follicle stimulating hormone, the follicle is going to grow. Luteinizing hormone plays a role as well, and we'll talk about that in a second. Inside my follicle, even after 14 days, I'm going to still have an oocyte of some flavor, but now it's actually a secondary oocyte, and it's sitting inside a mature follicle. So I'm going to draw you a mature follicle. And you'll see, I mean, I'm not even going to do it any semblance of justice because mature follicles are gigantic. At the beginning of the cycle, follicle stimulating hormone stimulates, up to 20 follicles out of your 500,000 in your ovary to start to develop. And as the process goes along over the course of 14 days, not all of them. Usually it's just one who reaches the stage of the mature follicle, and there's a whole bunch of processes in between here. So the mature follicle is surrounded by a type of cell called a granulosa cell. There's a reason I've done it in green. I'm going to tell you that follicle stimulating hormone stimulates granulosa cells. And so my granulosa cells are what I'm drawing right now in green. And take a deep breath because you'll see in a second why I'm drawing it like this. This is a mature follicle, and these right here are all my cells. And do you agree that they are like little square, cuboidal looking little cells? And don't they look like, oh, they're ready to do some jobs here? And I'm just trying to show you that there are layers and layers of cells. And looks like layers and layers of cells. And right here, inside here, this is a space called the antrum, and there's fluid in here. And actually, the granulosa cells are producing that fluid. Like they're growing really fast. Why are they growing? They're growing really fast because of the follicle stimulating hormone. They're also growing really fast because they're producing more hormones. Oh, ovarian hormones. Like we're going to have another whole story that we have to talk about here. There aren't just granulosa cells there are also cells called thecal cells, not fecal cells, fecal cells. And LH is the hormone that gets the thecal cells going. The thecal cells are the guys that are going to produce estrogen. So look, the thecal cells surround the outside of the mature follicle. Now, primordial follicles, I mean, we might draw like some little like baby lines like, oh yeah, there's some precursor out there, but really the thecal cells start to develop with the influence of follicle stimulating hormone. They start to develop. Now, I think that what we want to talk about is who is being produced by my thecal cells. These guys are going to produce estrogen. How am I going to do that? I'm going to go like this and say that they're going to produce estrogen. And if you can imagine that we started out with like none, and we end up with, whoa, there's a lot of them because that's a huge mature follicle, and all those outer cells are producing estrogen. And the interesting thing is that they produce a molecule that then diffuses into the granulosa cells, and the granulosa cells do like some modification and like give it a kiss, and now it becomes actual estrogen. So the granulosa cells and the thecal cells are working together to produce the estrogen. But what are you going to expect to happen to the levels of estrogen in your system as this happens? Okay, well, let's go talk about estrogen. But of course,